let's consider a particle that is moving along a straight line. Let's place the x-axis on the straight line along which the particle moves, with an origin point in a positive direction of our choice. This gives us a reference relative to which we can specify the position of the particle at any point in time. Let's also use a clock so that we know the time at which the particle has a particular position on the x-axis. As the particle moves, with this setup in place, we see the time at which it has a particular position, and we can specify what that position is relative to the x-axis. Let's say that at some instant t1, the particle is at position x1, and at some subsequent instant t2, the particle is at position x2. The change in position that occurs between t1 and t2 is equal to x2 minus x1. This is often indicated with delta x. The interval of time between t1 and t2 is equal to t2 minus t1. This is often indicated with delta t. So, how do we define the average velocity of the particle? The average velocity of the particle between an instant t1 and a subsequent instant t2 is equal to the change in position that occurs in the interval of time between t1 and t2 divided by the interval of time itself. Therefore, if we use the symbol v bar to indicate the average velocity, the formula for the average velocity is v bar equals to x2 minus x1 divided by t2 minus t1. That is, the change in position that occurs in the interval of time between t1 and t2 divided by the interval of time itself. We can also indicate this with delta x divided by delta t. In other words, the average velocity v bar for an interval of time delta t is equal to the change in position delta x that occurs during that interval of time divided by the interval of time itself. Therefore, what the average velocity measures is the average rate of change of position with respect to time.